There's a shape in mathematics that feels genuinely wrong. Not wrong because it's complicated. The math is just calculus. It feels wrong because it forces you to accept something that shouldn't be true. Take the graph of y equals 1 over x, starting at x equals 1, running forever to the right. Now rotate that curve all the way around the x-axis, like you're spinning it on a lathe. You get a horn. Wide at the left end, tapering down infinitely to the right. This is Gabriel's horn. Torricelli described it in 1643. The name Gabriel came later, presumably because it looks like the horn you'd blow at the end of the world. Here are two questions about this shape. How much liquid would it take to completely fill it? And separately, how much paint would it take to coat the inside surface? You'd expect those to have similar answers. They don't. Volume first. When you rotate a curve around the x-axis, the volume it sweeps out is pi times the integral of the function squared. For y equals 1 over x, that's pi times the integral of 1 over x squared, from 1 to infinity. 1 over x squared decays fast. As x grows, this function collapses towards 0 quickly. Fast enough that even though we're adding it up all the way to infinity, the total stays finite. The integral evaluates to 1. So the volume is exactly pi. About 3.14 cubic units. An infinitely long horn, and you could fill it completely with roughly a can of paint. Now surface area. The formula for the surface area of a rotated curve is 2 pi times the integral of the function, with a correction factor for the slope. That factor is always at least 1, so surface area is at least 2 pi times the integral of 1 over x. The integral of 1 over x is the natural log. And log of infinity is infinite. More concretely, this is the harmonic series. 1 plus 1/2 plus 1/3 plus 1/4, going on forever. It's one of the first genuinely surprising results in calculus. The series diverges. Incredibly slowly, yes, but it never stops growing. So the surface area of Gabriel's horn is infinite. Volume pi. Surface area infinite. Same shape. Fill it with 3.14 units of paint, and you've apparently touched an infinite surface with a finite amount. Except you haven't painted anything. You've filled the horn. The paint is sitting inside, touching walls that get thinner and thinner the further in you go. The tube narrows so fast that a finite amount of liquid fills it completely. But that same narrowing isn't fast enough to keep the surface finite. Here's why the numbers land differently. Volume depends on the radius squared. 1 over x squared goes to 0 fast enough that the integral converges. Surface area only depends on the radius directly. 1 over x goes to 0 much more slowly, and slowly enough that the integral blows up. Two functions. Two different rates of decay. One converges, one doesn't. There's no paradox to actually resolve here. Mathematics doesn't have a rule saying that if you can fill something, you can coat the inside. That rule holds in the physical world because physical objects can't be infinitely thin. In mathematics, they can. Gabriel's horn is a clean example of how infinity breaks physical intuition. Not flashy, not complicated. Just two numbers for the same shape.